It's that the cause, and here we'll be looking at the chemical properties of oxygen. Don't forget that these are properties that have to do with changes in the chemical composition of a substance. So look at number one, the reaction of oxygen with metals. How does oxygen react with metals? Oxygen reacts with most metals to form basic oxide. Basic oxides are simply called bases, and these basic oxides are ionic in nature because oxygen is a non-metal. When a non-metal reacts with metals, it gives you ionic or electrovalent compound. When you expose group 1 metal to oxygen, it reacts quickly with the oxygen and form metal oxide. But if you heat this group 1 metal with plenty amount of oxygen, instead of giving us oxide, it gives us the peroxide of those metals. As you can see in this place, when you react sodium with excess oxygen heated, it gives you sodium peroxide. So the diagram you see, or the picture you are seeing by my right hand side, is how the reaction normally occurs in the laboratory. Noble metals such as silver, gold, platinum, palladium, copper, you call them noble metal because they are not very reactive. They are not reactive metals. They don't react with oxygen under any condition. How does oxygen react with non-metals? Since oxygen is a non-metal itself, it only reacts with non-metals to give us covalent compound. Covalent compound. The same way you react oxygen with metals, you can also use a metal spoon, you call it deflagrating spoon, to also react non-metals with oxygen. You just put that deflagrating spoon and put your non-metal inside it. Use the spoon to dip the non-metal into the gas jar containing oxygen. Then there will be reaction and the non-metallic oxide will be formed. These non-metallic oxides are usually acidic oxide, just like metallic oxide with metals are basic oxides. For non-metallic oxide, they are acidic oxides and they are covalent in nature. Example is SO2, CO2, NO2. They are all acidic oxide and they are formed when non-metals react with oxygen. These oxides of non-metals that dissolves readily in water to form acids, they are referred to as acid anhydride. When you dissolve them in water, they give you acid and you call them acid anhydride. For example, if you dissolve SO2 in water, it gives you H2SO3. That's an acid solution. CO2 in water gives you H2CO3. That's also a weak acid. NO2 is a mixed anhydride because it gives you both HNO2 and HNO3. It gives you mixtures of two acids. So you call it mixed anhydride. Oxygen reacts with compound by splitting the compound and forming oxides of the element inside the compound. Take for example, when oxygen reacts with CS2, it splits the carbon and sulfur to give you compound, that's oxide of carbon, CO, and oxides of sulfur, SO2. That's how oxygen reacts with compound. With H2S, oxygen will split the H2S, form oxide of hydrogen, that's water, also form oxides of sulfur, SO2. The same thing is going to do to ammonia under a catalyst. It gives you NO2, that's oxides of nitrogen, also give you H2O, that's oxides of hydrogen. With hydrocarbon generally, it gives you CO2, that's oxides of carbon, and water, that's oxides of hydrogen. So this is how oxygen reacts with compound. It splits the binary compound and form oxides of the two elements inside the compound. Oxygen reacts with metals in the presence of moisture to corrode them. You call this corrosion. Corrosion in iron is called rusting because the product that is formed is called a rust. The chemical formula of rust is Fe2O3.X of water, called hydrated iron 3 oxide. So when iron reacts with oxygen, wherever water is present, it's going to give you Fe2O3.X of water called rust. This is rust. And that pack name is called hydrated iron 3 oxide. This vehicle placed in a moist condition for a long time has already turned brown. That brown color is rust. Rust is brown in color. Formation of ozone. When you pass oxygen through a silent electric discharge, as you can see, this is oxygen supply now, and this electric discharge, that oxygen will convert to ozone, and that's how you produce ozone from oxygen. So oxygen is turned to ozone through a silent electric discharge. It must be silent because if there is spark, the ozone will turn back to oxygen. The reaction is a reversible reaction, you can see in this place. So ozone can turn back to oxygen whenever there is heat or there is a spark. That's why you use a silent electric discharge to convert oxygen to ozone. And this is what we're going to be taking on the chemical properties of oxygen.